James Webb's discovery of these red dots was completely unexpected, especially not so early, so numerous, and so bright. When astronomers first looked at some of the deepest images ever captured by the telescope, they saw tiny red dots of light scattered throughout the young universe. At first, they seemed almost insignificant and commonplace. The universe is full of red objects. Distant galaxies often appear red because their light has stretched during their journey through expanding space. But as researchers began measuring these faint red dots, a disturbing truth emerged. Many of them turned out to have existed only a few 100 million years after the Big Bang. Even that would be exciting. The problem was their apparent size. According to models astronomers had developed over decades, there shouldn't have been enough time for such large galaxies to form. It was as if someone had opened a history book, glanced at the first few pages, and discovered that entire civilizations already existed where only scattered villages were expected. For years, our view of the early universe seemed quite simple. After the Big Bang, the universe entered a long, dark period. The first stars slowly ignited. Small galaxies appeared. These merged into larger structures. Over billions of years, the universe pieced itself together piece by piece. Growth took time. Complexity took time. The formation of giant galaxies took a long time. Then the red dots appeared. Some of the earliest observations from the James Webb Space Telescope pointed to galaxies that appeared surprisingly mature when the universe itself was still young. Researchers began comparing measurements, checking instruments, redoing calculations. When a result contradicted expectation, the first assumption is usually not that reality is wrong, but that something is missing in the observation. Throughout the history of astronomy, apparent anomalies have often disappeared after better data became available. But the strange pattern did not disappear. Deep field observations revealed objects that were larger, brighter, and more complex than expected. What made the discovery particularly disturbing was not that astronomers found a single unusual object. Astronomy is full of exceptions. What was worrying was that similar candidates consistently appeared in independent observations as well. Different regions of the sky seemed to tell the same story. The further researchers pushed their observations towards the cosmic dawn, the more frequently they encountered galaxies that appeared unexpectedly mature. A coincidence can be overlooked. Ignoring a pattern is much harder. The deeper astronomers went, the stranger the situation became. To understand why, it's helpful to remember what James Webb was originally designed for. Unlike earlier observatories, Webb fused the universe primarily in infrared light. This allows it to detect extremely distant objects whose visible light has been stretched to longer wavelengths by cosmic expansion. In a sense, Webb works like a time machine. The farther away an object is, the further back in time we see it. A galaxy observed 13 billion light-years away appears as it existed billions of years ago, not as it is today. When Webb looked at these distant periods, astronomers expected to witness galaxies gradually merging. Instead, some observations showed that significant structures already existed at a surprisingly early stage. New observations further complicated the story. Some of the earliest estimates relied on measurements using brightness at different wavelengths to determine distance. Later observations provided more precise measurements for some candidates. In a few cases, the most extreme estimates became less extreme. Some galaxies turned out to be closer than initially thought. Others appeared less massive after closer examination. To some observers, this seemed to have eliminated the anomaly. But even after re-examination, many galaxies still appeared unexpectedly evolved for their age. Astronomers began to examine assumptions they had felt comfortable with for years. Models explaining star formation and the early universe were re-examined. Simulations that had successfully reproduced many aspects of cosmic evolution now faced a new challenge. Small differences in efficiency, gas dynamics, or feedback processes could produce dramatically different results over hundreds of millions of years. What seemed like a small adjustment in theory could reshape the appearance of the young universe. Then something else emerged. The red dots weren't just interesting because of their brightness. They highlighted a deeper point about how scientific understanding has evolved. Most people imagine science as a collection of answers. In practice, science is often a collection of models. This usually works quite well until observations begin to explore areas where these simplifications become relevant. The early stages of the universe may be one of these regions. The expansion of the universe is still being observed. The cosmic microwave background is still present. Large-scale structure still follows recognizable patterns. The puzzle is more specific than that. The puzzle is about how quickly complexity emerges from simplicity. What makes this particularly fascinating is that the same laws of physics seem to govern everything involved. Gravity hasn't changed, nuclear fusion hasn't changed. The basic framework of cosmology has remained remarkably successful. But similar rules can produce dramatically different results depending on the circumstances. Small asymmetries in the early stages of the universe eventually transformed into galaxies, stars, planets, and observers who could question their origins. This transformation occurred through familiar physics. This is where the red dots begin to transcend astronomical curiosity. They reveal a subtle weakness in human intuition. We tend to imagine the universe evolving smoothly and predictably. We expect complexity to emerge gradually, almost patiently. But nature often works through thresholds, instabilities, and feedback loops. Under the right conditions, change can accelerate. Structures can emerge faster than expected. Systems can organize themselves with surprising efficiency. The universe doesn't necessarily violate our models. Sometimes it explores possibilities that our simplified mental images can't foresee. As more observations like James Webb's come along, this theory will continue to evolve. New research, more precise measurements, and increasingly complex simulations will reveal details that remain invisible today. The red dots are important because they remind us what discovery really felt like. Not the clean certainty of textbooks written after the event, but the unsettling period before the picture became clear. For a long time, the early universe seemed distant enough and expansive narratives sufficed. Then, a telescope a million miles from Earth was turned on, pointed toward the oldest light it could find, and revealed something unexpected. Not a broken universe, not a universe that defies physics, a universe slightly stranger than the version we carry in our heads. And if entire galaxies can emerge where we only expected beginnings, perhaps the most important lesson isn't about those distant red dots. As we refine our ability to observe reality, we also risk discovering that the simple story is never actually the complete story.